Okay, this is, again, part 2 of the test, a practice test, and problems 23 through 29. And for these problems, we ask, how many significant figures should the answer to each of the following calculations contain? And the options are A, 1, B, 2, C, 3, D, 4, and E, 5. And in parentheses I say, don't do the calculation. So I'm not actually looking for the results. I want to know how many significant figures should those final results contain. And this is given by the rules and the conventions with significant figures. And so we have to look at the operations themselves. There are elementary operations. There's addition and subtraction, which follows one convention. There's another convention that is for multiplication and division, and yet a third convention that applies to the characteristic and the mantissa containing the significant figures. And so all three of those are the ones we're going to have to check. And so we have to look at the operations. And in number 23, we have the operation of subtraction. With addition or subtraction, the final result can contain no more digits to the right of the decimal than the fewest of any of the summands. And in this case, I'm looking at 61.987054 minus 10.2, which has the fewest to the right of the decimal. The second term here has only 1 to the right of the decimal. This one has 1, 2, 3, 4, 5, 6 to the right of the decimal. And now we do have to look at how many are to the left of the decimal, because all of the results in this the final number are significant. And so there's only 2 here, and 61 plus 10 is going to be 71. So there's only, or minus 10 is going to be 51. So it's still going to be only 2 to the left of the decimal and only 1 to the right of the decimal. So that means there's going to be 3 significant figures. And for that option, that is C. Now, for number 25, it's another addition problem. And so I've got how many to the right of the decimal is what we focus on. 3, 2, 1, that's 3. 1, 2, 3, 4, 5, 6, and 1. So I'm restricted to only 1 to the right of the decimal again. But in this case, I've got how many to the left of the decimal? Well, there's 1, here's 2, and here's 2 again. And so there's not going to be any more than 2 to the left of the decimal and 1 to the right of the decimal. So that means my final result is going to contain, again, 3. So this would be option C. Now for number 26, the operation is multiplication. Reiterating a theme that I'd like to point out here, all of what we're doing, it turns out mathematically there are 2 basic operations, a way of combining things. One is multiplying and the other is adding. And all of this turns out, all of our studies at the end of the day turn out to be knowing when to add and when to multiply. And so here we have multiplication, and with multiplication, the results can contain no more significant figures than the fewest of any of the factors. Since it's multiplication, it's factored into these various factors. This is the first factor. The factors here are contained in parentheses. And so the fewest of any of the factors, well, we have to know when zeros are significant or not in order to understand this. A zero is significant when it occurs to the right of a number that's to the right of the decimal, or between 2 non-zero figures. And so here I've got 1, 2, 3, 4, 5, 6, 7 significant figures. Here I've got only 2, because these zeros are not significant. So this particular factor has only 2 significant figures in it. This one has 1, 2, 3, 4, 5, 6, 7, 8 significant figures. So my final result can contain no more than the fewest of any of the factors. In this case, this is 2, because these zeros are not significant. Okay, if I had a decimal point there, they would be. But there aren't. If I had another number over here, they would be, but they're not. They are to the right, but they're not to the right of a number to the right of the decimal. So they are not significant zeros. And so I'm limited to 2, and that would be option B. Now, the next is another rather more of a composite, and this has some that are following the scientific notation, some numbers in scientific notation. This is proper scientific notation. This is improper scientific notation. Due to what we would call the mantissa term here, and the number, the power of 10 being the characteristic, those are not significant. These are order of magnitude numbers. But ultimately, I'm looking at the composite operation here is division. And the fact that I'm taking the square root is almost irrelevant in this case. You know, I have to look at the operation which is division, which is similar to multiplication, and I look at the term preceding it. The absence of a decimal point in this, what we can refer to as the mantissa part of it, there's only one significant figure here because these 2 zeros are not significant. Now these 3 are all significant, so I'm restricted to 1 significant figure. The fewest of the factors is 1, and so that would be option A. Now I got another set of numbers in number 28. These are both in the proper scientific notation where there is a number between 1 and 10. And so this one contains 1, 2, 3, 4, 5 significant figures. This one contains 2 significant figures, or as Lewis Black would say, 2 significant figures. And so the fewest here is 2. And that would be option B. And here we are with our last example, and this is one where we've got an exponential form. And we have to recognize that this is a true characteristic mantissa situation here. The exponent divides the number into 2 parts, and there's the part to the left of the decimal, which is called the characteristic, which contains the order of magnitude information. And then the numbers to the right of the decimal contain the characteristic, the mantissa, or this is called the mantissa, contain the precision. These are the significant figures. Whatever is to the left of the decimal is only characteristic and is order of magnitude. It is not significant. These are significant. So this is 3 significant figures, and this is 3 significant figures. So in this case, there are 3, the fewest of a factor. So we're actually, the operation here is multiplication, but multiplication of 2 exponential numbers, we divide it by into the characteristic and mantissa, the characteristic being order of magnitude, the mantissa being the precision. We've got 3. So that would be option C.